Welcome to qnawire.
Okay, we are told that there's a reaction in which a single molecule of methane reacts with, it's not entirely important, but we're told that it reacts with two molecules of O2 to produce CO2 and two molecules of water. And that when this reaction proceeds, the delta H is negative 802.3 kilojoules per mole. And we're asked to express in grams how many, what mass of natural gas, CH4, we would need to burn to generate 273 kilojoules of heat. Okay. So what you may notice is that, hey, this isn't kilojoules, this is kilojoules per mole, right? If we divide the kilojoules of heat that we want to produce by the kilojoules that we produce per mole, that'll tell us how many moles of reactant we would need to produce 273 kilojoules, right? That is, we can simply take this 273 kilojoules, divide it by 802.3 kilojoules per mole. And note that I'm not including the negative sign here because we're talking about generating 273 kilojoules of heat, and this negative sign simply tells us that the reaction generates heat. Okay. And then if we do this reaction, no matter what number we get, notice that we'll have moles left over as our unit, right? And that mole is going to correspond, because there's an implicit 1 here, this happens for every 1 mole of CH4, that this will tell us the number of moles of methane, right, that we would need to generate that much heat. There's a correspondence, a 1-to-1 correspondence here between the moles for reactants, units of reactions, and our 1 mole of methane. If we were talking about O2, we would have to include this factor of 2, but not in this case. Okay, so what is 273 divided by 802.3? I'll do this off to the side. 273 divided by 802.3, and we will get 0.34027 moles of CH4. Okay, and then at this point, we know moles of CH4, but we need to know grams, mass in grams, so we could look up the molecular weight of CH4, and we get that it weighs 16.04 grams per mole, meaning if we take 0.34027 moles and multiply it by 16.04 grams per mole, moles will cancel and will be left over with grams, and our number will be, let's find out, we need 16.04 times, 16.04 times 0.34027, and we get 5.45. I'll just say 8 grams, and then our significant figures, we should have 3 sig figs, right? Because we have 3 sig figs in this figure here, meaning that our final answer should be 5.46 grams of methane.